So standard form must begin with a number strictly between 1 and 10. So in this case, we'll write 5.23. In this case, it would be 2.03. We'll keep going until we reach just zeros and then we can stop. This would be 6.01. Just be careful here. This looks like it's in standard form, but it isn't, because again, this number isn't between 1 and 10. So we'll write that as 2.4. And similarly here, 8.2. So we've got everything now between 1 and 10. And of course, all of these are going to be times 10 to some power. Now, if there was a decimal point here in this number, it would go there. And what we can see is that this has moved 1, 2, 3, 4, 5, 6 place values. And this is a large number we can see, so we'll put the 6 there. And I think you're fairly happy with that. Just an important point to bear in mind, what we're trying to achieve is this number and this number must be worth the same. It'd be if you won this prize in the lottery, whether I said you won this amount or this amount, it'd be the same amount. Again, the decimal point, if it was going to go, if I was going to write it on, it would be here. 1, 2, 3, 4, 5, 6 place values. Fine here because the decimal point's already there. 1, 2, 3, 4, 5. We've moved the other way and it's going to be to the -5. Of course, the shortcut way of thinking about it is this is a large number, so that's going to be positive. This is a small number, so it will be negative. And you won't go far wrong if you think on those terms. This is interesting because it needs to be worth the same. I've made this 10 times smaller because if there had been a decimal point, it would have been here, and I've moved it one place to the left, so it's 10 times smaller. So that we're all square, I'm going to have to make this 10 times bigger by raising it 1 power. So now this is worth exactly the same as that. That's important. And the way to think about this is you're balancing it out. 10 times smaller, therefore 10 times bigger. Here, this one, we've made this 10 times bigger. We've gone from 0.82 to 8.2. So because we've made this bigger, we'll make this 10 times smaller. 10 to the 4 rather than 10 to the 5. And of course, I haven't put an example on it, but if I'd sort of say 0.82 times 10 to the 5, and I wrote 8.2, 1, 2. Now this is moved to 2 place values. So it's 100 times bigger because it's 2 place values. So I need to make this 100 times smaller. It'll be 10 to the 3. So hopefully you've got the idea, balancing it out there. Changing standard form to an ordinary number. Well, we're going to move this 5 place values. And so 1, 2, or 1, 2, and I'm running out of space. So look, I'll just give myself a few zeros so I can keep track of where this decimal point is going. So 5 place values, 1, 2, 3, 4, 5. So it would go there. And if I want to write it tidily, yeah, we can drop. I don't need the decimal point in there, so that's what we get. This is a small number. I can see straight away it's a small number because that's a minus. I can put the 204 in. But my decimal point, because it's a small number, my place value is we're going the other way. So I'll give myself a few zeros in this direction so I can keep track of what's happening. 2.04, so the point is there. 1, 2, 3, 4, 5. And that would be our ordinary number. So that's the way of thinking about it. Just give yourself plenty of zeros so you can keep track of the decimal point as you move the place values. Right, important that you understand the technique here. I'm going to look at these separately in so much as, first of all, I'll do the 2 times 6.2. Now that might be a problem in and of itself if it's a calculator paper, but I've picked nice numbers. 2 times 6.2 is going to be 12.4. And then I'm going to do 10 to the 5 times 10 to the 4. And this is where your rules of indices come in. You should know that we're going to add these to give us 10 to the 9. And you may be very pleased because look, we've done this, but hang on. This is not in standard form. It's not strictly between 1 and 10. I've made this 10 times smaller, so I'm going to make this 10 times bigger by increasing the index by 1. Again, with division, we'll treat it separately. 6.3 divided by 2.1. Again, that can be a problem in and of itself. You might have to go away and do that with some separate working out, pen and paper. But I've been quite nice. It turns out to be quite a nice number. And we're back to the indices. 10 to the 5 divided by 10 to the 2. And again, we know that we would subtract in that case. Yeah, and so there we have that. Adding and subtracting, and what some students do, they change these into ordinary numbers, add them, and change them back into standard form. And that is a bit long-winded. It works, but it's a bit long-winded. When we add things, you've heard of the expression collecting like terms. We can only add things that are the same. You know, if I asked you what is 1/8 add 2/8, you could give me the answer instantly, 3/8, because we're adding eighths, 1/8 and a 2/8. But you couldn't add a quarter to a third. You couldn't add them directly. We'd have to change them into equivalent fractions. So you cannot add things together that are different, and these are different because this is 10 to the 5 and this is 10 to the 4. They're different. What I'm going to do is change them both to the same. So I'm going to change this to 10 to the 5. Now I've made this 10 times bigger because I've gone from 4 to 5. So I've got to make this 10 times smaller. And now I've got these, they're both 10 to the 5s. So 2 times 10 to the 5 plus 0.6 times 10 to the 5 will be 2.62 times 10 to the 5. So I'm just adding them together. And it's just the same with subtraction. They've both got to be the same. So I'm going to make this 10 to the 5. I've made that 10 times bigger, so I've got to make this 10 times smaller by moving the place value one place. And then I can just subtract them. 6.3 minus 0.21. 10 to the 5s. It's going to give me 6.09. So hopefully, this will be helpful.